All right, in this problem here, we want to write a polynomial. This is going to be 16 through 20 in your review. With leading coefficient of 1 that has exactly 3 distinct zeros. So we want to write 3 zeros. We're given the zeros with the multiplicity. Anytime it's multiplicity 2, it's double root. So if x equals -2 is your 0, your factor is going to be x plus 2. Always switch the sign. Switch the sign of the 0 to get the factor. But since it's multiplicity of 2, we're going to put a square there. X equals 3 is going to give you x minus 3. And that has a multiplicity of 1. So we don't have to worry about a square. And x equals 4 is multiplicity of 1. So it's going to be x minus 4. And it says write a function to model these criteria. You're going to put them all together. You're going to have your x plus 2 squared multiplied by your x minus 3 squared times your x minus 4. And you'll want to multiply these together. So let's do this. We'll do 2 at a time here. This is going to be kind of a bigger one. So I'm gonna focus on this one right here. X plus 2 squared is going to be x plus 2, which is going to be x squared plus 2x plus 2x plus 4. That's going to be x squared plus 4x plus 4. And then this one's going to be x squared minus 4x minus 3x. And then -3 times -4 is 12. And those are going to combine to x squared minus 7x plus 12. This is, again, multiplication, so this is a 3 by 3. So let me put this in here, x squared, 4x and 4, x squared, -7x, 12. And let's multiply that out. That's going to be x to the 4th power, 4x cubed, 4x squared, -7x cubed. -7 times 4 is -28, x squared. -7 times 4, again, is -28. And that's just going to be x. That's going to be 12 there. So 12 times x squared is 12x squared. 12 times 4x is 48x. And 12 times 4 is 48. So combining all your like terms, you're going to have x to the 4th. You're going to have -7 plus 4, so that's minus 3x cubed. 12 and -28 and 4. Add those together. 12 minus 28 plus 4 is -12, so -12x squared. And then finally, we got 2 more. 48 minus 28, that's 20x plus 48. So there is your multiplied out problem. Now you're going to want to graph this because on the exam it's going to be multiple choice. So what you can do is the following. So what I'm going to do on this problem is I'm going to graph my expressions here without them being multiplied together. X plus 2 squared, that double root, x minus 3 and x minus 4. And we can verify that it's got a double root at -2 and roots at 3 and 4. Now if I go over here to this graph, both the blue graph is without multiplying. The green graph is what I just multiplied together, x to the 4th minus 3x cubed minus 12x squared plus 20x plus 48. It is the same graph. And so, if you had 3 other choices that gave you different graphs, you would know, well, hey, those are incorrect. This is going to be the right one. So you can use your graph to kind of assist you if you need to on this problem. All right, number 17, let f of x equals 2x squared minus 2x plus 3, and g of x equals -3x squared plus 4x minus 5. What is f of x minus g of x? So we're going to write that out. 2x squared minus 2x plus 3 minus, so then we're going to use parentheses because we want to distribute that negative. That's a negative right there. Don't forget that. So -3x squared plus 4x minus 5. So a negative, when you're subtracting, you're going to want to distribute that negative. So it's going to be negative, negative, which is going to be positive. That's going to be negative, and that's going to be positive. And so you can rewrite it as 2x squared minus 2x plus 3 plus 3x squared minus 4x plus 5. Combine your like terms. 2x squared and 3x squared will give you 5x squared. Negative 2x and negative 4x will give you negative 6x. And then the 3 and the 5 will give you 8. All right, number 18. And this one is division. We're going to want to use synthetic division on this one. So let's go over that process. First thing you're going to do is you're going to do the opposite. So negative 3. You're going to write that in the box. Look at your exponents. Fourth power, third power, x to the first power. We're missing a squared power, so we need a 0 there. So we'll have 2, negative 4, 0, 3, and 1. See if you can get that. Pause the video if you need to and try it on your own. We're going to bring down the 2, multiply here. 2 times negative 3 is negative 6. Add down. Multiply again. Negative 10 times negative 3 is 30. Add down. $30 times negative 3 is negative 90. Add down. You're going to get a pretty big number here. Negative 87. Negative 87 times negative 3. Need to use my calculator on that one. That's going to be 261. And so if I add those together, you're going to get 262. Now those should be right. Those are awfully big numbers here, but let me just double check my numbers, make sure I'm not making a mistake. Let's see, negative 6, negative 10, 30, 30, negative 90. Yeah, those are right. So your final answer, since this was a fourth power, you're going to bump it down to the third power. So it's going to be 2x to the third power minus 10x squared plus 30x minus 87. And then you're going to put your remainder plus 262 all over your divisor, x plus 3. So that is how you do synthetic division, and you can do that with long division, but I'm going to stick with synthetic on this problem. All right, see, number 19, graph 2 minus 6x times x squared minus 2 in Desmo. State the right and left end behaviors using the correct notation. So what I do here on the right side, actually, I like to do the left side first. So I'm going to say left side. You're always going to say as x goes to negative infinity, y goes to something. And then on the right side, you're always going to say as x goes to infinity, y goes to something. So you gotta remember that the only thing that's going to change is what you're going to put in after the y arrow. And sometimes they'll have the right and the left switched in places, so you might see the x going to infinity first and x going to negative infinity second. So either way here, your left end behavior is when x goes left, x goes to negative infinity. Your right end behavior is when x goes right, x goes to infinity. Now, as far as getting the rest of the end behavior is going to go, we're going to graph it. So when you put that in your graph, you'll see that this graph here opens up on the left side and down on the right. Again, it's going to go up on the left side and down on the right. So your graph, since it looks like this, on the left side, it's going up. That means y is going to go to infinity. On the right side, it's going down. That means y is going to go to negative infinity. And that's how you do your end behaviors here. Number 20, last one on this video. What's the remainder when x to the fourth minus 12 is divided by x plus 3? There are two ways to do this. One way is to use synthetic division, but you're going to have a lot of zeros. Third power, second power, and your x value. You're going to have 3 zeros there. So you're going to have 1, 0, 0, let's see, fourth power, third power squared, x negative 12. This is going to be minus 3. And bring that one down, multiply, negative 3, add, multiply, add, multiply, add. 27 times 3 is 30, 60, 90, 81. So and then you're going to add down and you're going to get 81 minus 12, which is 71, 69, I believe. Might want to verify me on that one. So that's certainly a way to do it. Then the other way to do it is to plug in negative 3 in for x. This avoids having to do any of the zeros. So if you do negative 3 to the fourth power minus 12, and you can use a calculator on that if you need to. Again, make sure you're using parentheses when you're plugging that in. Negative 3 to the fourth power, 81 minus 12, and you can get 69 that way too. But since it only wants to know the remainder, you don't have to go ahead. You don't need all this other extra stuff. Just remainder, and you can get it one of those two ways. All right, thank you for watching.